Okay, changes within the nucleus in alpha, beta, and gamma emission. Now we have read that radioactive substances are not stable. Their nucleus undergoes spontaneous decay by the self-emission of either alpha, beta, or gamma radiation. Okay, why they want to radiate? Because they want to become stable nucleus. Okay, now for achieving stability, they are actually emitting the. And can you tell me what is the reason why they are not stable? Because they have more neutrons. Because they have
and
more
less
neutrons.
protons.
Yes, because they have more neutrons and they have less protons. So basically, to attain stability, what they will try to do, they will try to break the neutrons and they will try to emit it. Okay. Now, what happens exactly when the radiations are coming out? The emission of alpha, beta, and gamma radiation is a nuclear change. That means whatever changes are happening, it is happening inside the nucleus. Now, in emission of alpha and beta radiation, there is a change in the number of protons and neutrons inside the nucleus. Okay. That means there is something else happening. Protons बढ़ जाएंगे या प्रोटॉन्स नहीं, प्रोटॉन्स बढ़ेंगे नहीं, प्रोटॉन्स डिक्रीज हो जाएंगे. ओके, न्यूट्रॉन्स भी डिक्रीज हो जाएंगे. while in the emission of gamma radiation there is only a change in the energy of the nucleus. So when gamma is radiating there is no change in the proton or neutron or electron. Okay, there is only change in the energy of the nucleus which is very big. So basically when gamma radiation is happening तो बहुत ज़्यादा energy निकलता है and that is called nuclear energy. But there are no changes in the number of proton and neutron. Now, when alpha emission is happening, what is happening? So, when an unstable nucleus, okay, contains much more neutrons than the number of protons, okay, then it may emit. Okay, so now it is not sure, okay, कि alpha होगा या beta होगा. So, it may emit a particle containing 2 proton and 2 neutrons tightly bound together. Now, if you remember, हमने पढ़ा है, alpha particle is all about what? It is like an helium particle, but it is what? It is only helium nucleus. It doesn't have orbital electrons. Remember हमने पढ़ा था. So basically what happens when alpha is emitted, okay, that means a helium, sort of a helium nucleus is being emitted or alpha particle. Now there are some changes happening in the parent nucleus. That means parent nucleus से क्या हो जाता है? Now if the atomic mass number 4 निकलता है, okay, so what will happen? So what is going to be my daughter nucleus? That means there after uranium, so जो uranium तुम्हारा radioactive substance है, and there is an alpha particle coming out, that means there is a daughter nucleus which is going to be formed. Now, what will be the atomic mass number and atomic number of the daughter nucleus? So, it will be, so assume the daughter nucleus is of Y, matlab it's a Y thing. So, what will be the atomic number? Atomic number minus 2, matlab Z minus 2 hoga, and the mass number it will be minus 4. Now, why it is minus 4? Because when a helium particle is coming out, that means 2 proton and 2 neutrons.
2 neutrons.
So therefore 2 proton plus 2 neutron, it is 4. Therefore atomic mass of the new daughter nucleus will be A minus 4 and Z minus 2. Okay, any doubt? So if
मैम ये in case of helium ही है क्या?
yes, this is only because of alpha particle. हर एक चीज का अलग changes, like when beta particle is coming out, something different will happen. We have a table also. Okay, so if a nucleus X of a radioactive element of mass number A and atomic number Z emits an alpha particle, the daughter nucleus of a new element is formed which has mass number equal to A minus 4 and atomic number equal to Z minus 2. So therefore you can see the mass number is also decreasing as well as atomic number is also decreasing. Atomic number is decreasing by 2 units and mass number is decreasing by 4 units. Okay, thus the resulting
मैम
nucleus,
उसका
बोलो.
उसका रीजन क्या है मैम? वो मास नंबर क्यों ज्यादा कम हो रहा है?
अरे अभी तो बोला 2 protons and 2 neutrons.
वही है
Atomic
क्या?
mass
अच्छा
number.
सर
So when 2
हाँ
protons
हाँ
and 2 neutron का helium particle निकलेगा and helium में उसको 4 दिख रहा है यहाँ पे. This is the mass number. Mass number क्या होता है? What is the mass number? Total number of protons plus total number of neutrons.
माइनस टोटल नंबर ऑफ न्यूट्रॉन्स.
तो proton plus neutron is 4. तो atomic mass number क्या रहेगा? A minus 4 daughter nucleus में. And what will be the atomic number? Minus 2. ठीक है?
ओके समझा मैम. थैंक यू मैम.
Okay, so they have given an example. The exam में आएगा. They will be giving you an equation and they will be asking you. What they will be asking you? They will be showing that it is emitting an alpha particle. What is the atomic mass number of the daughter nucleus and what is the atomic number of the daughter nucleus? They will be asking that question. तो आपको क्या करना है? जो भी existing nucleus है 238 है. 238 minus 4 करना है and it will become 234. 92 minus 2 करना है. That means it will 90. So my daughter nucleus will be having 90 protons and 144 neutrons. How can you calculate neutrons? कल हमने बताया था A minus Z.
A minus Z.
Okay, so this is A. A is what? Proton plus neutron, और सिर्फ न्यूट्रॉन चाहिए, then it will be A minus Z, इसलिए 144 न्यूट्रॉन्स लिखा हुआ है. Now let's understand the beta particle. When an unstable nucleus contains neutrons more than the protons, a neutron may change into a proton. That means now क्या हो रहा है? Neutron is what? It's uncharged. There is no charge to it. लेकिन क्या हो सकता है? कल भी मैंने डिस्कस किया था. Neutron may break into a proton, okay, an electron. And what is beta emission? It is the electron emission. Okay?
Electron emission.
हाँ, so this electron is coming out from where? It is coming out from the nucleus at a very high speed. This is not orbital electrons. This is nucleus के अंदर का neutron टुकड़ा होके electron बनता है. So now if you have neutron, now if you see atomic number of neutron is 0 because it is not charged. And neutron का क्या है? Proton नहीं है ना, इसलिए 0 and 1. So when it is breaking down, one neutron is breaking down into two things, proton and electron. Proton में क्या रहेगा? Atomic number is 1. Atomic mass number also will be 1. Why? Because atomic mass number of proton will be 1 plus 0 because there is no neutron. So 1 plus 0 is 1. Therefore, the atomic mass number of proton is 1 as well as atomic number of proton is 1. What about the beta particle? Now you already know that electron is negatively charged and it has negligible mass. है ना? तो ना प्रोटॉन
Yes.
है ना न्यूट्रॉन है, तो आंसर इज 0. सो एटॉमिक मास ऑफ एन इलेक्ट्रॉन इज 0 because it's negligibly very small. And what about the atomic number? It will be the charge. What is the charge of an electron? It is -1. It is negative charge. Okay, so this is the beta particle. Now a stream of beta particle is called beta rays. फिर एक ही इलेक्ट्रॉन एमिट होगा क्या? नहीं, it will be a stream of beta particle. Okay, now this is something एग्जाम में इतना कुछ आता नहीं है. There is something, okay, it is assumed, it is not assumed actually, later on I think किसी ने तो assume किया था that beta particle, it is so high energy, okay, just to balance in both the side there is another particle is coming out, okay, मतलब so you don't have to remember much about it, मतलब ये एग्जाम में आता नहीं है, but you can just write that another particle is called anti-neutrino is also assumed to be emitted along with the beta particle, and this particle is uncharged and it is a rest, and the rest mass is 0. Now when can I say something is uncharged, or when it is only a energy? It is just an energy. Okay, so I already said that beta particle is of very high energy. Okay, now to balance it there is another something which is coming out, that is anti-neutrino. So you don't have to worry about this because ये बहुत later someone had assumed कि ये anti-neutrino है, बट बाद में किसी और ने एक्सपेरिमेंट करके प्रूव किया दैट यस देयर इज सम अदर पार्टिकल आल्सो कमिंग आउट, और उसका नाम किसी ने एंटी न्यूट्रिनो रखा है. ओके, जिसके लिए उसको नोबेल प्राइज भी मिला है, बट दिस इज नॉट देयर इन अ सिलेबस. So you just need to understand what is anti-neutrino. There is another particle coming out with the beta particle which is uncharged and the rest mass is 0. That's it. इतना ही लिखना है आपको. Yes, anyone? Any doubt? No. Okay, thus in emitting beta particles, see now notice what is happening. What will happen to my daughter nucleus? Okay, let's see example यहाँ पे देखते हैं. वो पढ़ने से अच्छा ना, I can just tell you what will happen to the daughter nucleus. Parent nucleus. Okay, so atomic number, what will happen? Atomic number will increase. क्यों? See, when a beta particle is coming out, there is that beta particle is coming out of a neutron. Neutron क्या कर रहा है? It is emitting one proton. So that proton will be added to the existing nucleus and it will give a new element. Okay, it's a new element, it's a new daughter nucleus. So just see the difference between parent nucleus and the daughter nucleus. If you see, atomic number is increasing by 1 but the mass number is remaining same. समझे आपको? So this one proton is getting added to parent nucleus, okay, keeping the atomic mass same. So what will happen? तो exam में आपको क्या याद रखना है? So they'll be asking you this question and they'll be showing you that one beta particle is coming out. So what will be the changes in the atomic number and atomic mass number? So if you notice, atomic mass number remains same and atomic number is
increases by 1.
1. ठीक है, वही लिखा हुआ है.
मैम
Yes.
ये कार्बन है ना, उसमें
yes.
जो 6 उसमें 6 इलेक्ट्रॉन्स है ना.
हाँ.
और जब वो नाइट्रोजन टू कन्वर्ट होता है उसमें तभी भी 6 ही रहेंगे.
नहीं, just
इलेक्ट्रॉन्स ऑर्बिटल्स.
Okay, so a radioactive carbon nucleus has 14 nucleons. 14 मतलब 6 प्रोटॉन एंड 8 न्यूट्रॉन्स, ठीक है। 8 न्यूट्रॉन्स में से एक न्यूट्रॉन टूटेगा, एक न्यूट्रॉन टूटेगा तो क्या होगा, 1 प्रोटॉन विल बी जनरेटेड। नाउ दैट 1 प्रोटॉन is there in nitrogen, matlab 1 proton will be added to the carbon, okay, 1 proton will be added to the carbon and it will become a nitrogen, and what happens to that beta particle, it is going to come out. So if you see nitrogen, yes, 7 proton and 7 neutrons, yes bolo।
मेरा डाउट था कि जो कार्बन एटम है ना उसमें ऑर्बिटल इसमें 6 इलेक्ट्रॉन्स रहेंगे ना,
हाँ,
तो वो जब नाइट्रोजन टू कन्वर्ट होता है तो उसमें और एक आता है क्या?
okay, your question is कि एक और इलेक्ट्रॉन ऐड होता है क्या? yes, see the element changes, yes आता है, बोलो कैसे। see the element itself is changing। जब एक न्यूक्लियस में, सी लिसन, जब वो जो न्यूक्लियस में एक न्यूट्रॉन जब टूटा, ओके, वो प्रोटॉन का बाहर जाता है क्या? नहीं ना। दी कॉम्पोजिशन, एंड याद रखना ऑर्बिटल इलेक्ट्रॉन्स क्या होता है, देयर इज अ ट्रांजिशन ऑफ एनर्जी, मतलब एक इलेक्ट्रॉन, दो इलेक्ट्रॉन ऐसे ऊपर नीचे होता ही रहता है, ओके। सो व्हाट विल हैपन, इट विल बी लाइक एन अनआयोनाइज, जैसे एक कम इलेक्ट्रॉन दिखाएगा तो क्या होगा, इट विल बिकम n प्लस, समझा क्या तुमको, ओके। बट द होल कंपोनेंट चेंजेस, पूरा एलिमेंट ही चेंज हो जाता है, क्योंकि वो न्यूक्लियस में एक बीटा पार्टिकल निकल गया, बट उस न्यूक्लियस में एक प्रोटॉन बैठ गया, ओके। तो इट विल बी लाइक n प्लस हो जाता है वो, मतलब एक इलेक्ट्रॉन, एक ऑर्बिटल इलेक्ट्रॉन कम दिखाएगा,
मतलब प्लस चार्ज रहेगा ना उस पे?
यस, प्लस चार्ज रहेगा, ओके। बट वो एलिमेंट चेंज हो गया, मतलब वो अभी कार्बन नहीं रहा, बिकॉज उसका न्यूक्लियस चेंज हो गया, ओके। सो व्हेन यू आर एडिंग वन प्रोटॉन, it becomes, the element itself is changing, but the not necessary that एक ऑर्बिटल इलेक्ट्रॉन भी कहीं से पैदा होके आ जाएगा, नो ऐसा नहीं है, but it will become n प्लस, मतलब वो एक क्या बन जाएगा, कैटायन बन जाएगा सॉर्ट ऑफ, ओके।
नाइट्रोजन नॉर्मली एनायन रहता है ना पर?
हाँ, यस यस, तुम ना ये सब पूरा कंसेप्ट है ना, तुम तो क्लोरीन को भी प्लस देखोगे नेक्स्ट ईयर, मतलब तुम सरप्राइज हो
मैम
जाओगे
सब
कि
अब 11th की बुक लेके बैठा हूँ भैया।
क्यों, व्हाई आई वांट, मैं क्यों 11th का बुक लेके
मैम
बैठी हूँ?
सब अच्छी बात, सब अच्छी चीजें 11th में ही है।
अच्छी बात है ना, खुश रहना,
आई नो,
तो पहले 10th पास कर हर्षल।
वही तो 10th पास ही करते
खुश
पहले।
रहना, तो जो दिख रहा है तेरे को।
Okay, so what happens in emitting a beta particle? The number of nucleons in the nucleus, sum of proton and neutrons remain same, but the number of neutrons is decreased by 1. हमने देखा ना, यहाँ पे एक, देखो ना, 6 प्रोटॉन से 7 प्रोटॉन बन गया, 8 न्यूट्रॉन से 7 न्यूट्रॉन बन गया, okay. So in other word, what will happen? The mass number is not changing. मास नंबर कैसे चेंज होगा, क्योंकि वो बैलेंस्ड ही हो गया ना, 6 प्लस 8 क्या था, 14, यहाँ पे 7 प्लस 7 भी 14 है। See, even though there is an increment of 1 proton and decrement of neutron, still the mass number remains same. वही बात करने की कोशिश कर रहे हैं वो लोग, but the atomic number is increased by 1, क्यों, क्योंकि एक प्रोटॉन इंक्रीज हो गया, okay. So it changes into a new nucleus with properties similar to those of an element one place higher in the periodic table. So the daughter product is an isobar, okay. आइसोबार बन गया ना, क्योंकि एटॉमिक मास नंबर सेम है, बट द एटॉमिक नंबर इज डिफरेंट, ओके। एग्जाम में यही आएगा, दे विल बी आस्किंग यू कि एक बीटा इमिशन हुआ तो क्या होगा, तो यू हैव टू राइट दिस नंबर्स, ये 14 7 ये सब लिखना पड़ेगा। सबसे बेस्ट है गामा, ओके। इन मेनी केसेस एन अल्फा और बीटा इमिशन इज फाउंड टू बी फॉलोड बाय गामा इमिशन। मैंने बोला ना कि यदि अल्फा इमिशन हो रहा है, अल्फा के साथ गामा भी निकलता है कभी कभी, और कभी कभी बीटा के साथ गामा निकलता है, okay. So it occurs when the daughter of the parent nucleus is in state of excitation, that is it has excess of energy, okay. तो सिर्फ अल्फा निकाल के उसको फर्क नहीं पड़ेगा, so it needs to take out more energy, that energy will come out in gamma emission. This extra energy is released in the form of electromagnetic radiation known as gamma radiation or gamma ray photon. The gamma ray takes no mass and no electric charge from the nucleus, okay. It's a pure energy, that is no neutrons or protons are lost, hence the nucleus does not decay into different nucleus, okay. Only one condition, that parent nucleus should be in excitation stage. Now what is the meaning of excitation stage? So basically उनके जो orbital electrons है ना, now it is about to jump from one place to another, ये भी तुम बाद में ही पढ़ोगे कि what is the meaning of excitation stage, okay. The star indicates the excited state of the nucleus, it's a very unstable nucleus, okay. तो thus in gamma emission the excited nucleus comes to its ground state, मतलब आफ्टर गामा emission क्या हो जाता है, थोड़ा सा वो एलिमेंट ठंडा हो जाता है, सिंपल। Now note, the electron emitted in beta decay does not exist in the nucleus, ओके ये बार बार वही बोल रहे हैं कि इलेक्ट्रॉन कभी न्यूक्लियस के अंदर होता नहीं है. इट इज क्रिएटेड एज अ रिजल्ट ऑफ डीके ऑफ वन न्यूट्रॉन इनटू प्रोटॉन inside the nucleus and it is instantaneously emitted. सिंपल समझो, एक न्यूट्रॉन टुकड़ा होता है, प्रोटॉन उधर ही रह जाता है and that electron is emitted out. When the proton remains inside the nucleus, it changes into a new element. Okay, it is not possible for electron to stay inside the nucleus. That's why it has to be emitted. So in a single radioactive decay, alpha and beta particle are never emitted simultaneously. Okay, there will be either an alpha emission or a beta emission, which may be accompanied by the gamma emission. Okay, मतलब कभी alpha होगा तो कभी beta तो वैसे. But yes, gamma can be there along with any one of them. ठीक है, fine. तो alpha particle क्या होता है? That helium nucleus. हमने कल पढ़ा था helium nucleus. एक बार दिखा देती हूँ. People who have just joined for today only. Okay. Okay, where it is? हाँ ये देखो, this is the helium atom, and this is the alpha particle. So alpha particle does not consist of orbital electrons. Normally orbital कितने electrons होंगे? 2 electrons होंगे ना, but alpha particle में क्या होगा? There will be only nucleus. Okay, this is called alpha particle, and beta particle is just a fast moving electron. That's it. Any doubt in this?
No, ma'am.
Okay, the daughter product. Okay, the daughter nucleus after the emission of alpha and beta particle may again be radioactive. हो सकता है वो भी radioactive like thorium, polonium ऐसा होता है. So it may further decay by emitting either alpha or beta. This process continues till a stable nucleus is formed. Okay, now this table is very important. Okay, ये आपको याद रखना है. Alpha emission, in alpha emission everything is decreasing. Z is decreasing by 2, A is decreasing by 4. What about beta emission? Increases by 1. What? Atomic number. And atomic mass क्या होगा? No change. Gamma में तो nothing happens to the nucleus. Only it is क्या excited से ground state हो जाता है. Now uses of radioactivity, radioisotopes. The isotopes of some elements with atomic number Z less than 82. तो मैंने एक बार statement किया था ना पहले कि elements which are having atomic number more than 82 they are radioactive. But yes, there are some elements which are less than 82 like carbon. अभी पढ़ा था ना 14 वाला. Okay, that is less than 82, but they are still radioactive. So they are called as radioisotopes. The nucleus of an atom becomes radioactive when the number of electrons in the nucleus exceeds the number of protons inside it. Like for example, they have given you an example of cobalt. ये थोड़ा dangerous है हाँ cobalt. आपको नहीं मतलब बहुत easily medicine में भी use करते हैं. Okay, for some purpose. Okay. Now cobalt, if you notice 60, मतलब कितना atomic number is 27 and atomic mass number is 60. So you can notice that neutron is more than 27. Okay, so it is a radioisotope. What about carbon? 14 minus 6, 8 neutrons. So carbon 14th वाला जो carbon है that is radioactive. Similarly potassium का normally atomic mass number क्या होता है? 39. और यहाँ पे क्या दिख रहा है? 40. So this is also radioactive. Similarly phosphorus क्या होता है? phosphorus का I think it is 31. But यहाँ पे देखोगे it is 32. So it is more than the atomic number. Neutrons मतलब. Okay, how do you develop this? They are prepared artificially by nuclear transmutation. Okay, so you can prepare this. Now they find their vital use in medical, scientific and industrial fields. Okay, this is the thing I was telling you ना, cobalt बहुत use करते हैं ये आज के डेट में for treating cancer. So many diseases such as leukemia. What is the meaning of leukemia? I taught you circulatory में.
ब्लड का
व्हाइट
कैंसर
ब्लड सेल ज्यादा हो जाता है रेड ब्लड सेल से.
Yes, blood cancer. Now for treating leukemia, they use radiations because there is no other way. You have to, but उससे क्या हो जाता है? Some good cells also die along with it. Okay, so gamma radiations obtained from cobalt 60 are used to treat cancer by killing the cells in the malignant tumor of the patient. Okay, but this is very dangerous. Okay, again I'm saying, I'll tell you some story of cobalt later. Okay, now for radiotherapy, radiations must be able to penetrate the human skin. So you know already, gamma radiations are very strong. They have the extreme penetrating power. इसलिए तो उसको lead box में रखते हैं ना, यही पढ़ा था ना कल हमने. Okay, they can pass
Yes,
through.
ma'am.
Now there are some other salt. ये तो हमको पता है, like sodium chloride. नमक होता है ना, नमक. Now there is some different composition of sodium chloride. Those are called radio sodium chloride, then radio ion or radio iodine. They are used for diagnosis. Now what is the meaning of diagnosis? Now understand something, like if you have any issues inside your alimentary canal के अंदर कुछ प्रॉब्लम है, like intestine में anywhere, okay, you can't मतलब तुम्हें क्या करना पड़ेगा, you cannot take blood, मतलब blood का तुमने टेस्ट किया, यूरिन का टेस्ट किया, still you are not getting the answer कि प्रॉब्लम किधर है. ओके मतलब बेसिकली ऐसे जगह पे है दैट you cannot, you need to cut it and then only you can see it. Okay, मतलब some inside organ you need to trace it, especially I'm talking about alimentary canal. I hope you understanding. Okay, yeah, brain tumors, it's written already. So what they do, they मतलब normally I know because it has been done to my father-in-law, so I know about this. Okay, now these tracers, I'll tell you how it was done with him. Now these tracers are used to detect the suspected brain tumors and blood clots before they become dangerous. Okay, so when you're having a severe headache or okay, तब तुमको मतलब ऐसा कुछ तो, this is like what, okay, so I'll tell you what happens. The tracers are also used to study the natural process in the human body. Okay, that's okay. For example, radiosodium chloride is injected with common sodium chloride in the human body, and the radioactivity of the blood at different parts of the body is tested to study the blood circulation. This process is called radiocardiology. Now, this is talking about blood circulation. Okay, just 1 second. Hello? Hello?
Yes, ma'am.
Okay, so basically I told you, now you need to understand that if there is any blood clot happening inside your circulatory system, what they will do, they will try to inject this radiosodium chloride and they will trace it. Okay, I'll tell you one example which was done with my father-in-law. Okay, now, so what it was done, he was given a solution, a liquid. Okay, now that liquid had a color. Okay, now when they were tracing it, okay, by some instrument, they were able to trace the color. Okay, and that solution got stuck somewhere. वो ना कहीं पे जाके अटक गया. So he had a colon cancer. Okay, so in intestine it got stuck. So तब जाके पता चला, yes, there is a big tumor inside the large intestine and small intestine between them. So that was also a tracer, and the tracer was made using radioisotope. Okay, fine. Now the third part is gamma
Yes,
rays.
ma'am.
Okay, gamma rays emitted by radioisotopes are used to sterilize. Normally ऐसे बोलते हैं ना कि धूप में रख दो sterilize हो जाएगा. We have studied about UV lights also. It is used for sterilizing. Now gamma radiation is a very good sterilization. Now you are studying about coronavirus. Now coronavirus will not survive in UV also and gamma also. So certain viruses or certain things, मतलब सोचो sunlight से भी जिसको कुछ फर्क नहीं पड़ता, those viruses or those bacteria, they die because of gamma radiation. So sometimes you use gamma rays for sterilizing bandages, dressings, syringes and other equipments to make them free of germs. This method is quicker and more reliable and cheaper because आपको फिर heat generate करना नहीं पड़ेगा. So to generate heat आप क्या क्या use करते हो? Either you will be using some gas to generate the heat or you will be using electricity. That is more expensive. So gamma rays बहुत easily मिलता है. But yes, there are harmful effects also that we'll be studying. तो आपको आई होप यू अंडरस्टूड कि आपको एक कोई तो एग्जांपल पूछा जाएगा कि गिव अ वन यूज ऑफ रेडियो आइसोटोप इन मेडिकल फील्ड, सो यू कैन राइट एनीथिंग. सो नॉर्मली पीपल राइट अबाउट कोबाल्ट ओनली, वो इजी है, और यू कैन राइट अबाउट द ट्रेसर्स. ओके, या स्टेरिलाइजिंग. ओके, नाउ साइंटिफिक यूज. So scientific use मतलब basically nuclear reaction. So alpha particles emitted from radioisotopes are used as projectiles for nuclear reactions. Okay, projectiles मतलब basically like a rocket, मतलब यहाँ से वहाँ उड़ के जाता है something. So the scattering of, और एक चीज होता है, scattering of alpha particles helps in estimating the size of the nucleus. Now this you have already studied last year in Rutherford experiment. Okay, now you want to know the size of the nucleus. तुम्हारा nucleus कितना बड़ा है? You will be scattering or you will be bombarding the gold foil with alpha particles. वही है वो. Okay. The radioactive tracers are used in agriculture science to study the growth of plants by using a particular chemical manure. Okay, so you want to know how much the plant takes in phosphate. Phosphate is mineral. Okay, so how much it is consuming and which part is going. So this is just one of the example. They can study using tracers any like what do you say, any usage of minerals. ये तो सिर्फ फॉस्फेट की बात हो रही है, बहुत सारी चीजें, कैल्शियम कितना लेता है, सोडियम कितना लेता है, पोटेशियम कितना लेता है. Okay. Now this is very important and this is most interesting. This can come in your exam. Carbon dating. Okay. Now if you know, आपको पता चलता है ना, by seeing the fossil you come to know कितने साल पुराना है. कभी क्वेश्चन आया कि नहीं? उनको पता कैसे चलता है कितना साल पुराना है? How did they come to know? Okay. And if you remember कि किसी का मर्डर हो जाता है, they can actually predict कि कब मर गया वो इंसान. How did they come to know? Do you know this?
Carbon dating.
Yes, because of carbon dating. Can we join back?